Okay, hi Paul, Dr. Bill. Looking over your homework 3, and let's see what you got. I was looking at your problem 1, and just really nicely engineered code. I actually loaded into my IDE, ran it myself because I was curious about your step direction code. I didn't, for some reason, I didn't quite get what the break was doing at first, but then I understood it after I ran it. So you keep looping until a step that doesn't reverse the last one is selected, or if you're on the first step, in which case you could take any step because there's no previous step to examine. So you're doing good there. In general, when you're showing your code, you need to use a monospace font like Courier. You'll see like on blogs from professional developers and data scientists, you'll see them doing that, right? So the what I mean by a monospace font is that each character takes up the same amount of space. So this is not a monospaced font. This is more like a font you'd see in a book or something. So you want to, just you could use Courier. I'll show you how, right? You just select your code, change it to like, there should be one on the fonts list. Like I see one right here, like Courier New, right? So doesn't that look more like code, right? So use that when you're, showing people your code. Change the font to a monospace one. Okay, so you print your runs, but you only print 18 of them, and at least you printed some. I mean, I do warn people that I'm going to take 10 points off if there's less than 100 walks printed in the output for me to see in the report, like really specifically, and it's highlighted and everything. But still people miss it sometimes, but I can see that your code works and it's solid, it's easy to read, so you get a lot of kudos for that. So I'm not going to be too hard on it. Also, your stats are within the acceptable ranges, so it's evident that you did enough runs to get some solid stats. You talk about, and you gave your narrative, a sensible narrative, saying that they're largely consistent what you would expect, so on and so forth. So this is a good discussion there. Let's go to problem 2, the Levy flights. I'm just going to go straight to your code there. Right, so you expand the starter code. You choose a random angle for the direction. There should be 2 of those. One in the different dimensions. I'm not seeing them. It looks like. Wait a minute. I think that's just the starter code. I don't see your code. It says copy or paste your code here, right? I need you to actually give me your code. So your code's missing. Email it to me if you get this and you want me to evaluate it. I can't evaluate code I don't have. So I don't see the plots either. Okay, I need the plots literally in the report. Okay. Don't count on me to run the code to see the plots. Okay, I need them actually in the report. Okay, so review this. Okay, it says your report should include the following: a narrative describing the effects. Okay, you did talk about it. You gave the narrative, but literally the plots need to be in the report. Okay, 8 plots, minimum 8 plots, max 20 plots, varying alpha and beta, trying out different values. It's just not here. Okay. So if you want to, resubmit work on problem 2, let me know. I was somewhat of a miss, but I can tell that you sincerely did, some serious work on it. You have a thorough narrative, which is why I'm offering you this opportunity. I'm eager to see what the information that supports the narrative. So I'll stand by for that. Problem 3, just turn it in by Tuesday. Okay. I don't have to turn in the grades immediately, but next Tuesday, that would be a week from now, right after the term officially ends, you could give that to me, and if you send it to me over email, I'll take a look. Right, so problem 3, this was about least squares, the method of least squares for well, it starts out pointing out that's common use. The method of least squares is commonly used for data fitting problems, like simple line fitting, basic regression. For polynomials, it tends to result in higher order polynomials that would result in overfitting, okay? So, for a line, it's fine, but for higher order polynomials, like with, x squared, x cubed, x to the 4 terms, you could get some overfitting going on. And to address that, people have introduced penalty coefficients, a penalty in the coefficients to balance the goodness of fit and the choice of a reasonably simple model that doesn't overfit the data, some noisy data. If you overfit noisy data, you get a poor model. You do a thorough job on this, okay? You correctly identify lasso from the available literature. I don't see a specific citation of literature here, which is not bad. It's not bad. I mean, this is a really well-known method. Um, you'd probably do more math than you needed to. I just wanted you to describe an algorithm, not necessarily give all the steps. But when you offer math expressions, they need to be completed, okay? So these are not completed. Do you see the summation? It has no, do you see the first summation box? There's a dotted square there. That means you didn't enter any term in to be summed. Okay, so this is an issue. You have a condition, you have the vertical bar, like such that a sub k is equal to or less than capital C. That's there. It's incomplete, okay? C is not defined here. I don't see, oh, I guess later, step 5, you define it. Constraint level C. But again, the second summation, missing a term that's being summed. The same problem happens in the explanation. You have a bunch of those. It'd be better to do less math than to do math that's not readable. You could just try to describe the algorithm if you want to do that in your resubmission. Okay, problem 4, Markov. No narrative on this one, just filling out a transition matrix and printing your Markov chains, right? So you're running some code that generates some Markov chains. Okay, so first thing, transition matrix, that is not filled out. We need the actual probabilities. We got it started in the Zoom recording, okay? And I explained this in detail there before the homework was due. So if you look at, transition matrices, the examples, in the course materials, you see that the entries are probabilities. They're not these P to A. That's just, yeah, it needs to be the probability that you repeat state A. You need to give the numerical value, not just say P to A. Okay, so this is a problem. It's evident, though, that you have some sense of it, because you do have a transition matrix in your code, right? So you say replace these with the real probabilities from the graph. So, you did end up doing it, so I'm not terribly upset about this. You give the code, it looks like it's generating chains and that it stops when it reaches the threshold, which you said appropriately, the code's easy to read. You don't give the 100 chains. I'm going to clarify it to students, for the next cohort that, hey, these actual outputs need to be in the report. So I'm actually not going to penalize you on this one. So to review, so we're back from the top to the bottom, just quickly back to the top. So we had, which one was it? It was problem, okay. We don't have any plots for problem 1. Okay, we need to see, did we need to see plots? No, visualization is up to you on problem 1. That's not necessary. So that one's okay. It was problem 2 was the one, right? So you need to look at problem 2 and submit the supporting documentation, right? The plots. Okay. So that was missing. And print your flights too. So if you're gonna run 100 Levy flights, and actually print them in your report here. Okay. And problem 3 was I mentioned, just the missing expressions in the math. So this is those two problems really, problems 2 and 3 that need additional attention. And I'm giving you the opportunity to resubmit. So provided it's done within a week, so next Tuesday. Next Tuesday, so today is November the 18th, so next Tuesday would be November the 25th. Okay, thanks for your attention. You're doing some decent work there, Paul. Keep it up. Bye.